Since wherever you are today, I am going to be looking at dplyr. What is dplyr? It's a package in R. But before I tell you whatever it is and how to go about it, please do me a favor. Subscribe to this channel and, of course, share it, and also encourage other people to subscribe. We struggle a lot to put together this kind of content, and we don't have viewers, we don't have subscribers. We just want to improve on the data science capacity in Africa. And I believe that you would also realize the significance of this and then support us. Please do me this favor. Thank you. My name is Bigba Bright. I'm from KNUST, Ghana. Right, so dplyr, what is it about? Now, before I can say anything else, dplyr is a package in R. And then is one of the package that is used favorably when it comes to data transformation. We can also use dplyr for data visualization. We can use dplyr for even a very systematic or a flow data analysis. So it encompasses everything. How do we get dplyr? We can install it direct, or we can install tidyverse. So there are two ways of getting it. We can either install this package, using this kind of, or using this approach, or if you don't want that, you can simply just go to your console or any part of your RStudio, and then you just type install.packages into bracket, and then you are good to go. Now, after you have installed the tidyverse, it comes with dplyr. So you don't have to install the dplyr. But if you want, you can also install dplyr, and then you are good to go. For the purpose of this tutorial today, I want us to also install a package called NYC Flight 13. Yeah, it's also a data package, or it's also a package that has a data set on flight schedule, delay, departure, destination, and all those things. We'll use that one to be able to make our case. Now, after you have installed them, if you are new to R programming, then you might want to follow my playlist. You can check my playlist, and then I have the beginning part of the videos as to how you can install your R in your RStudio, and then the beginning part of where you have data structures, variable declarations, and whatsoever. You follow it systematically. So when you subscribe to my channel, I upload videos almost every 3 days, and that is it. So let's go. What is dplyr? I said is already used for data transformation, and it can also be used for data analysis. What does it do? When we say data analysis, we are simply talking about how to, pick out the exact information you want from your data. So how do you want it? You might want how to see the groupings. You might want to see the classifications. You might want to see the clustering, or you might want to see the pattern or the trend. You might want to see the minimum, the maximum, maybe the average. You might want to see some kind of correlation. You might want to see some kind of regression. You might want to see some model. All these things are data analysis techniques that we use to extract whatever information that we want. But before you do that, you have to transform the data. Sometimes the data is not in a shape that you'll be able to see all that I have mentioned. So data transformation is what we're going to do today. And we're going to use the package called dplyr. I'm going to profile 10 packages. So make sure you subscribe to this channel and you keep on, and turn on the notification bell. When I upload the next package, how to use it, you are good to go. So now we have our flight 13, and then we are good to go. So I've titled this packages in R. And so that's what it's going to be. All the script will be available when I finished. So we have flights, this particular, package, and then we have tidyverse. So let's load them. If I load tidyverse and I load the flight, then it's already loaded, so I don't have to. Now, within the NYC Flight 13, there is a data set there called flight. And then I also decided that let me also have my own data. So I simulated this data called cookies. It's actually a data set. I must give accolades to someone actually did that data on Excel analysis. And then I looked at the pattern of how he did it, and I simulated the data accordingly because I also wanted to repeat the same analysis. So that my data is also seated here, which is here. So we are going to be working with these two data sets, flights and then cookies. And so we can simply just have some few glimpses of it. If you want to look at, you can look at the structure of flights which are there. And so if we do like this, we're going to have the structure which is all seated over there. And that is it. And so we could also check for the structure of cookies. And then when you check, you're going to see all that we have there. Now, but before that, before the cookies data, I decided to simulate a date. So I use the sequence function. This one is sequencing. So you sequence as date. Then you state from the first date up to the last date. And then you simply specify whether you want it to be every 3 days, every 2 days, every day, or what. So when you say one, it means every day to count all the days. I ran this particular second line to exclude weekends. There are some companies that do not work on weekends. So I just simply use the same thing. So I go to the data, this particular variable I created, the same variable here. Then I use the index function to say that, okay, when you say exclamation mark, it negates whatever that is here. So we are looking for weekdays. So the opposite of weekdays, which is found in here, and then so it means we are simply excluding Saturdays and Sundays, and we pack the variable. So we call this one to write over. So we are going to write over the first variable in such a way that weekends will no longer be included. So when we finished, I decided to extract the year separately, the month separately, and then the days, pack them into these variables, which are here. And then I decided to now attach them to the cookies data, which was already there. And then this is how I attach it. So now when I finished, and then I do head, you can see that the cookies data will have the town, the food, the unit sold, the revenue, cost, profit, date, the actual date that I was having, the month, the days, and then the year. And so we are now good to go. So if you want to actually have glimpse, to catch glimpse of how the data looks like, it's going to come with it to tell you the number of rows, the number of columns, and then the description of each variable. That's the column headers. These column headers are what we call variables. What we see under each variable is called observation or entry, depending on the kind of data science tool you are using or data science language that you are using. And so these are variables. So if you want to catch glimpse and then have a description, what are these variables? You know, whether it's a character, it's a number, it's an integer, it's a float, it's a factor, you may not know. So when you run like something like a glimpse, so that's for the flight, it tells you that how many observations we are having. We are having about 333,776 rows. That's observations. And then how many variables? 19 variables. So each variable you can see here, and then the description is also here. So the integer, it tells you that it's an integer, it's a double. And then, of course, a double is like integer, but a double has takes like decimal places and stuff. So you can also have, we have minutes, we have hours, we have. So this is something I have taught in my time series analysis. If you want to simulate data on time, or on minute basis, on seconds basis, you can do that. And you can check that video on my YouTube channel as well. So these are the preliminary things that you can actually do. Now, how do dplyr work? Dplyr work with a very important function called pipe operator. The pipe operator in R, we can obtain it in two different ways. So I'm going to just click here. If I press Control, Shift, and M, I get my pipe operator. Then that's the pipe operator we have here. The same thing here. It's either you use this or you can use the pipe that we know together with this. It's the same thing. Now, if you don't want to be using this pipe operator we have right now, the percentage greater than percentage, which means pipe, to take something out of, so what do? You simply can just go to your, tools, or go to your, I think your tools, and then you go to your global options, and then perhaps you can go to, I think, code. And then when you go to the code, you can look at, there is this particular portion, so use native pipe operator. So if I tick this line, it means that I am now going to be using the native. That's the one that comes with R. So I'm going to take this and then go and press escape for this to go. And then now if I say press shift, control shift and M, and then, oh, well, I think I need to refresh my R so that before it will come. But that's how we are able to have the natural one or the native one. That is the one that was built with R, and then the one that we have now. Either of them work this just perfectly. Now, dplyr works, the data transformation works in two forms. We can work by rows, we can work by columns. Now, if we are working by rows, there are some functions that we use. We use something like filters, we use something like summarize, by group by, and then all of them to be able to transform the data into a form that we want. Now, when we are filtering, we are actually kind of picking some part of the data out. So here I have a data, I've already mentioned it, which is flight. So the flight is a data frame. Like we have already checked the structure, it's a data frame of a certain number of rows and columns, then in that order. So now when I put the pipe operator here, I'm simply saying that pipe out. So the whole of this is one line code. So immediately you bring the pipe operator and then you say enter, this indentation automatically comes and then you are good to go. So what are we piping? We are piping out something. We are piping out into the filter function what? Destination. So we are piping out into the filter function what? What are we piping out into the filter function? We are piping out destination. So this particular pipe operator will go into this flight data frame and then look for a variable called destination. And then it will check, well, destination, are you taking all the variables? No. We are saying that anything that matches I, A, and H, then pick that out. That's what we are filtering out. And when we filter that out, then we, from that particular destination, we are also going to pipe out another variable into the group by function. And which variables are that? Year, month, day. And then we also pipe out again into the summarize function, what? And we say arrival delay is equal to the mean arrival delay. And then we are removing all the non-available or if there's a missing data. So when we run that, this is what we are going to get. As you can see, this is what we are going to get. So that's a code that is a little bit maybe boring to you for now. Don't run away. I'm going to be breaking that code systematically for you to see how it works. So now I'm going to leave that part and then I'll come here and then look at the filter one after the other. And so this is how it is. So that's the flight data. And for the one that I have simulated. So I'm running this particular one for you to see if you want to look at the variables. I have a data frame called cookies. What are the variables there? The column headers or the column names. So we run the names, it will print the column names for you. As you can see here, I have town, food, unit sold, revenue in that order. That way, I will know what I can pick at any point. So from that, I am piping. So you can see that now I'm using the other pipe operator. It will just work the same way. So I am piping out what? I am piping into, I am piping out into the filter function, what? Town. And I'm saying that the town, if the town is Najo number 2, then we filter that out. And then we filter Najo number 2 out, and then we pipe that into group by what? Month, days, and then year. Remember, we also have these 2-3 variables. Now we pipe up again, and then we summarize based on total sales. Then we say mean, and then we have units sold. And then, units sold is here. So it will give us the total sales. And so this is going to be like a new variable that we have created. And then that's all. We run that, and then we can see that we are going to have a total sales then in that order. And then that's what is able to help us. What I want you to know is that it works this way. Maybe when I'm typing, so I have a data like cookies, right? And then this particular cookies, I'm going to pipe out. So if I do my control shift and N, the pipe operator comes. When you do enter, and then, okay, so let me clean this. If I come here, if I say enter, it will indent the line automatically. So what do I do next? And I'm saying, all right, which function am I going to use? Because I'm using dplyr, I'm going to use filter because I'm working with rows. What am I going to what am I piping out into the filter function? Let's say I am piping into the filter function something like food. Okay, the food, but I'm not just filtering the food component. Even though if I leave it at this point and then I run it, it may not make any sense. So you're going to have a problem. So if I just say food, because I am filtering, what am I filtering in the food? When you use double equal sign, if you are following my tutorial, you should know what that means. In the food, maybe let's say we are going to, we are piping out a particular food called, sorry, we are filtering out a particular food called, let's say, kuli, then in that order. If you run that out, it's going to bring out only that particular part. And you see, it will just take only kuli, and then from scenario number 2. And then when we filter out, filter doesn't mostly work just alone like that. So we are filtering out, and then we come and say shift. Then we pipe out again, and then enter and say, what are we piping into? We are piping into a function. Which function is that? We say group by. So we have the group by what? By the month, you see, and then by days, and then we have by year, and then we are good to go. So now we have by month, by days, and then by year. So first of all, what are we doing? We are going into the cookies data frame, and we are going to pipe out into the filter function food. And what food are we piping out? Not all the food, we are piping out kuli. And from there, we want to group wherever kuli is based on months, based on days, and then based on years. And then that's up to that point. Let's run it and see what we have. And then at this point, I'm not making too much sense. And so once we are using group by, it's important for us to also do summarize. We have to also do summarize. So you use the pipe operator again and pipe whatever that you have already done into, again, summarize. And so you're going to have the summarize, summarize. I'm not too sure if this British and American English it can. So we are going to summarize, and then I can just do this. That's what I've done. And then I write between there, I'm saying that I want total, so I can say I want total revenue. Okay. And so once I want the total revenue, that becomes a new variable. I'm just simply coming here. And then I'll simply just write, how do I want the total revenue to be calculated? So I'm going to come here and say mean. What is if you use mean? Mean of what? Mean of maybe the revenue. And remember, we already have a function, or we already have a variable called revenue. So we have our revenue there. But it's always important to remove NAs. So NA dot remove, and then we say is true, even though I know I don't have missing values, but just put it there for the sake of. So when you do that, you run that. Okay, so I see some little challenge here. A group by month, days, you can override using the dot groups. Yeah, which I could have easily done. I just demonstrated this for you to see how, this pipe operator thing is being done. So here, this is how it's the same thing we have here. We filter out from the cookies data frame. We filter, we pipe out into the filter function town, which is the same as scenario number 2. And then we group it by month, days, and years. And then we also say we summarize it based on total sales, and we have the mean. We find the mean of the units sold, and then that's all. The same thing here, we filter out into, we have quickly, we also pipe out into the group function, the month. You see the same month here, days, the same days there, year, and the same year there. And then we summarize it based on total revenue. This is a new variable we've created. And then we say the mean is the revenue, and then we remove the .NAs. And that's what we have just done over here. Now we'll be breaking it down small. So we come here, we are saying that from the flight data, we have to filter, we are piping into the filter function what? Departure delays. Departure delays that was greater than 120 minutes. 120 minutes, that's about, I think, 2 hours. You see? So that's what we are going to do. So when we run that, we're going to have, so it's going to give us the departure delays. So you can see the departure delays which are here. So all that were more than 2 hours, we isolate. And so these are the departure delays that were more than 2 hours. The flight which had a delay of more than 2 hours. So we can see them here. And so that's what it does. So we isolate that particular, maybe that's all that we need to do. Here, I am also piping out into the filter function, profit, that is greater than 4,000. So we'll go into the profit function. So it's going to go into the profit variable and then select all the profit variable that are greater than, and then we see how that works. So if I go to my data frame now, I can see that it has filtered any profit. If you go to the profit variable now, everything you see here is greater than 4,000. That's the profit area. So now, flights that departed on a particular day, all right? So if it is a particular day, let's say it is 2nd January, 2nd January. And then remember, we had partitioned our data into days, month, and then year. So what do? We filter out, or we pipe out into the filter function a month. And that month, the month category, we have 1 for January, 2 for February, in that order. So when I say month, which is the same thing as 1, I am saying January. And then if I'm looking for January 1, I will say N. This is ampersand. Ampersand means N. So, and day is equal to 1. So it means 1st January. So we just want to look at the flight that occurred on 1st January. And then to simply just print out all of them for us. So these were the flight on 1st January. So what about if I want to find out the flight on, let's say, on Valentine's Day, the flight on Valentine's Day, you see? So we could have said that, okay, we have our flights. What is it like this? And then we simply use our pipe operator and come down. We are piping into what? The filter function. And then what? We are looking for the flight that departed on Valentine's Day. Valentine's Day is what? Valentine's Day is 14th February. So we have to select the month first. So we simply say we have our month here, and then we are looking at a month that is the same as 2. And then we have our ampersand and say that we are also looking for days that are also, or a day that is also the same thing as 14. And so when we do this, we can check all the flights. You see, these were the flights on Valentine's Day that we can actually check. These were the flights that took place. And so there are various ways through which we can do this. Now, when we get to my own data, let's say that we want to also check what our cookies, our sales, our profit, our cost, our revenue on Valentine's Day. It's the same thing I just did here. So I will filter, or I'll pipe out into the filter function the month, which is equal to 02, or I could have done 2. Then the days, which is equal to 14. That is on Valentine's Day. How was our business doing on Valentine's Day? Check. Because it's a single day, it summarizes everything for us. And then check. This is for 2022 and 2023. And we can check how much revenue we made on that day, the costs, the profits. And we can see that, 2022 did better than 2023. As we can see the profit margin here, 1944 and then 1094. So that's how we pick out part of the data and then do whatever we want. Now, this is N. It is called N, ampersand. If you want to compare two things, you want to say this one and that one. You see? But it can also be or. So we want to check the flights. How many flights, we are looking at the number of flights on either January or February. So when we do that, so we say the month is equal to 1, or this pipe operator is called or, So in that case, we are not looking at N. And then so it will print all that happened on January, and then all that also happened on February. And that's what we are doing. It's the same thing I've repeated here for the cookies, and then in that order. So if I pull this up, you're going to see how there it is. Now, a shorter way to select all that I have done is you could also filter, or you could also pipe out into the filter function, just say month. Okay. And then this is called member of. So we want to find out this particular month. Is it a member of 1 and 2? Is there, so this is what, January and then February. So a month that is a member of this, yeah, it is there, and then this. So we run it. It's the same thing that's what we have done here on top over here. The same thing that will also be done here. Now we can save the results. It's the same thing, or we can save the results. So we create a variable that's January, and then we check all the flight that took place on 1st January, January 1. So I will just run that, and then the results will be packed here. I think you should know this. And then we can also look at the sales on Valentine's Day, and that's what I have already done, how to save the results. So next time, if I print Valentine's Day, I can have all the sales that took place on that day. And then you can see Valentine's Day sales whatsoever. They are all here. And so now we can also use another function in dplyr called arrange. So the arrange, it changes the order of the rows based on the value of the column. And so here I am piping into the arrange function, year, month, day, departure time, and then that's it. So it will rearrange it for us. So if we run that, we can see whatever that is happening here. And then on the cookies too, the same way. But these two lines may not make too much sense unless we use this function or argument called descending order. So it will arrange it. So here we are piping into the arrange function the delays, and then we are arranging them in a descending order. So when we do that, okay, so what do we see here? So it will arrange the variable that we have piped out. It will arrange that one in a descending order. So delay. So we can see how it is from the highest all the way to, and so we can see the number of minutes here. So like 1,000, I think this was a whole lot of delay. And then we can also have 896 minutes, and then in that order. That's not all. Some rows are here, but we are unable to print all the rows, and then in that order. So with the cookies, let's say we want to arrange it according to revenue, from the highest revenue to the lowest revenue. And this was, so we use the pipe operator, we pipe into the arrange function, revenue, and then let the arrange it in a descending order. That's all we have done there. And so we just run this, and you see how it works. So if I go to the revenue, you will see that this is our revenue. You see that 23,900, 23,100, 27,106, then in that order, up to 22. It goes all the way to 1,000, 15,000, then in that order. So it will arrange it in a descending order. Descending means from highest to lowest. So now this is another function that we use. Now we can also use distinct. Distinct actually find out some unique values, ones which are there. If you don't have unique values, then that is it. But if you have a duplicate, the unique is able to print out to let you identify the duplicate. I don't have duplicate, so you can see that they are all in here. Now, we can also find all unique origin and then destinations. So like we are looking for those origins that are are not or are unique. Let me use the same word. So I am piping into the distinct function, origin, and then destination. So two, and then that's what I've done here. And so these are the unique in terms of origin, and then in terms of destination. These are the unique ones. Okay. Now we could have also done the same thing with the cookies, and then we can also have our unique town and then the unique. So we have Najo number 2 here and Kulikuli, Najo number 2 and Kose, then in that order. You will see Najo number 2 again. Instead of seeing Najo number 2 repeatedly, now you now see it only once. And see Kulikuli repeatedly, you see only once. So it only picks, it tells you that these values, even though it might appear like 15, 45 times, it's just one. It's just like the way we have factors and then it can give us levels. It's practically the same here. Alternatively, if you want to, keep other columns along, when I do this, when I run the distinct, you see that only those variables that are selected comes. So what do? We could actually extend it. We can extend this by saying, using an argument called keep all is equals to true. So I'm saying that I'm piping into the distinct function origin, destination, and I'm saying that keep all. So it means you see that it keeps everything, and then that's it. So it will take the origin, the destination, and it will say keep all of it. You can see the origin and the destination here because it's on the other part. There's a way to make sure that they come at a particular place where you want to have it. For instance, it is hidden. You can't see it, but it has worked. So if I come here, the same thing, I am piping into the distinct function, what town, food, and I say keep all. So that way, so we check something here. Instead of now having the big data that I was having over 700 variable observations, now I have just 30. So that's what has happened. So it will simply pick Najo number 2, Kuli, and then have all the variables on this particular day, 27th, and then in that order. But here it appears it's picking just the first row, and then in that order. Now that's the first row appeared on the 27th January. 27th January 2021, then in that order. And so this is practically how we can expand it. Let me clear this and pull this down a little bit. And so now, what's the next thing? We can also find the number of occurrences. You see, what we have done on top here, you could not count. But here, what we are doing, we want to count the number of times that the distinct variable that we have is there. So here I am piping out into the count function. So we use count to be able to do that. The origin, the destination, and we say sort is equal to true. So it will count it for us. And so here is the same thing. And so let me run my own data. And so it will create a new variable automatically called n. And so here we now have town, food, and then the new variable is called n. So it tells me that Najo number 2 Kulikuli appear 42 times, Atebobo Kulikuli appear 40 times, and then Tumu Kulikuli appear, and then in that order. And so you can see how they all run up to the last one. And then that is it. So that's what we use the count function for. And then so when we are using count, we are using distinct, we are using filter, and we are using summary. It means we are working on the rules in dplyr package. If we want to work on the columns, we are going to transform the data by columns. And transform the data by columns, we use the functions like mutate, you see, and then the mutate allows you to create a new variable. Then the new variable would have some kind of interaction. But I'm going to leave here, and in the next video, I will show you how to be able to also use the dplyr package to transform your data using by columns. So I don't want the videos to be too long, and then this is how it works. So thank you, and I will see you in the next video. Bye-bye.